Let's talk about 2024 AMC 10A problem 20. Let S be a subset of 1, 2, 3 all the way to 2024, such that the following two conditions hold. If x and y are distinct elements of S, then the absolute value of x minus y is greater than 2. If x and y are distinct odd elements of S, then the absolute value of x minus y is greater than 6. What is the maximum possible number of elements in S? So, how do we solve this problem? Well, there isn't really any formula for this, I guess, or any specific answer or way you do this. So, the first thing you would do is probably experiment and see what S actually looks like when you try to fit as much elements as possible in S, right? So let's say we start with the integer 1. The next element would probably be 4, because 1 plus 3 is 4. And that's the smallest number that you can add to 1 to get the next element. And then the next number would be 8, because 1 plus 7 equals 8. And if we were to do 1, 4, and 7, 7 and 1 would have to have an absolute value of 7 minus 1 would have to be greater than 6, but clearly that's not the case, so it has to be 8. So 1, 4, and 8. And then next number that is possible would be 11, and then 14, and then 18, etc. All the way to 2018, 2021, 2024. How many numbers are here then, right? At least if we figure this out, we might be able to eliminate some options. So there are 3 numbers in every cycle of 10. So that's 202 times 3. And then the last 2 numbers here plus 2. That is 608 numbers. So we know that these 2 answers are not correct. Okay, so how do we know if 608 is the answer or not? Well, notice that the maximum amount of numbers that you can fit into one cycle of 10 is 3 numbers here. Why? Because, okay, so there aren't that many there aren't that many possibilities here. So let's just list everything out, I guess. It's not that difficult, right? So we have, if we start with 1, we have again 1, 4, 8, or we could have had 1, 4, 9, but either way, there's only 3 elements. Okay, so let's say we didn't want a 4, we wanted a 5, because that's the next number you can do. Then, wait, actually no, that is not the next number you can do. The next number you can do is a 6, right? 1, 6, and then what? 6 plus 3, 9, right? 1, 7, you can't do 7. 1, 8, well, that's 2 elements. That's even worse. So any bigger number won't work. Now, what if we start with 2? People might say, oh, that makes this a lot better, right? What if we started the subset S with the element of 2? Well, 2 plus 3 is 5. 5 plus 3 is 8. So there's still 3 elements. If we didn't want a 5, 2, 6, 9. That's the best you can do. Or 2, 7, and 10. That's over. That's not 3 elements. That's 2 elements, right? So this doesn't work. Okay, so if we start with 3, 6, and then 10, which doesn't work again. So I think you get the idea here. You can list everything out. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can start with all of these numbers because there isn't that much cases here. And when you don't really know any formula or theorem here, then the best way is to just list everything out. There isn't that much cases, right? There's at most 20 cases, I guess, which isn't that much if it actually gives you 6 more points in the AMC. So basically, realize that the largest amount of elements you can have in one cycle of 10 here is 3. And there's only 3 elements. So no matter what 3 elements you choose, the maximum number would be 608. Why? Because 2021 and 2024 fit right in. Like, if you chose some other number, if you started with 2, and it's like 258, then this would be 2022. Like, this would be 258 something, right? 2022, 2025, which is not even in this subset. So S would have 607 elements, which is like even worse because we want a maximum possible number of elements. So the answer is obviously C.